All right. So basically, this will be the reference sheet that's posted tomorrow morning for virtual people. People in class, you'll get a physical copy yourself. All right. So you have all the formulas except for rhombus. So you're going to have to add, see where kite says A equals 1 half D1 D2. You're just going to have to add rhombus when you walk in the door. You got it? So you just got to add that one. Everything else, now there's stuff on here we haven't done yet, like regular polygon, can't wait, circle, then we got some volume, got some more volume. Here's something that might be helpful though. Well, look at there. What do you got? Got a little Pythagorean theorem action. You got your special right triangle, so it's there. So the formulas are there. You also got some conversions down there. Some of the measures of the interior angles. Look at that, 180. Wow, look at all that. How swell. It's a lot of information. So it's all there for you. You'll get a physical copy of it tomorrow. So for those of you that like to prepare and you know what's going on, so everybody got that. So you'll have all that. Just got to add the rhombus. All right. So going back to what we're talking about, which is this figure, the kite. All right. Remember, this is x root 3, and 2x. So this is when, recall from chapter 9, the 60 degree, which is x root 3, is not in the best place because it's an integer value. So x root 3 is equal to 12. All right. And you either have to remember that the net result is something, or you have to actually physically do the division, but that makes x 4 root 3. All right, so we're asking you to recall what you did earlier in the year. So that's 4 root 3. All right, and then the hypotenuse of the 30, 60, 90 is double the short leg, so we got 8 root 3. Then you have to remember property of a kite. If that's 4 root 3, then this is also what? 4 root 3. Then we come over here and we got a 45 degree angle, so the legs are congruent. So if that's 4 root 3, that's also what? 4 root 3. Do I now have both parts of both diagonals? Yes, I'm good to go with area. 1 half D1 D2. Okay. 1 half D1 D2. So 1 half D1 can be 8 root 3. Everybody okay with that? And then D2, I'm going to erase and slide over. I'm not going to have enough room. So 1 half 8 root 3. And then the other diagonal is 12 plus 4. Everybody good? All right, you can take care of the 1 half right away if you like. What's 1 half of 8? 4. So now we got 4 root 3. 12 plus 4 root 3. And then to finish it all off, we're going to distribute. 4 times 12 would be 48, so that'd be 48 root 3. Plus 4 squared is 16. 16 times 3 is 48. And boom, shakalaka, centimeters squared. And that, my friends, don't forget, is exact. All right.
How'd you get to the 48?
4 times 4, 16. Square root of 3 times the square root of 3 is square root of 9. What is the square root of 9? Ray, what's 3 times 16? Good?
That's it.
Yes, sir.
You put it this here.
Like you could, oh, you're just talking about the order which you write it? That's fine. It'll take either one. Or if you want to get really fancy, 48, 1 plus square root of 3, but I don't think you're just adding work. I would say just be aware of that multiple choice somewhere along the line, but yeah, it'll take any of them. All right, so we're good with the special right triangle component of tomorrow's quiz. All right, so anytime you see 30, 60, or 45. Okay, now for the fun. The perimeter of a rhombus is 100 centimeters. If one of its diagonals measures 480 millimeters, what the? Is that a mistake? No. Centimeters and millimeters, you got to convert. All right? Centimeters and millimeters, you got to convert. Now, I'm not telling you how to live your life, okay? But you can go about it two ways. You can either change, obviously, the centimeters and millimeters. The advantage there is it's probably easier because you know that there's 10. However, you're going to have really big numbers. Okay? The other way of going about it is turning the millimeters into centimeters. And from earlier in the week, I would do it before you do any calculation. So in other words, 48 millimeters would be 48 centimeters. Okay? There's 10 millimeters in a centimeter. All right? So now I'm going to go to work. It's a rhombus. With a perimeter of 100. What am I going to do with that 100? Divide by 4. Makes them all the sides 25. What kind of angle is formed at their intersection? Right angle. It says one of its diagonals measures 480. Moved it to 48. These would be 24. Doesn't matter which one you label, because it's bisect. We have ourselves two sides of a right triangle. What theorem are we going to use to get the third side? Pythagorean, 24, 25. Whether you use PT or triples, you're going to end up with 7, which means this one's also 7. So now I got area equals, and it's a rhombus, so 1/2 D1, D2. The D1 and D2 are obviously interchangeable. Just don't forget to multiply by 2 when you do it. Now 50, 48. Everybody good with that idea? 14 times 48, what is the half? Half of 14 is 7. 7 times 48 is 350 minus 14. I'm going to go with 336. All right, we converted to centimeters, so our final answer is centimeters squared. Since there are 10 millimeters in a centimeter, you square the 10. What is 10 squared? 100. So 33.6 followed by a pair of zeros, millimeters squared, if you needed to convert. All right. Yes, ma'am. You can't do it both. You can't do half of both. You're only doing half of one. I make the same mistake all the time, so I understand exactly what you're saying. So basically, the problem is a lot of kids will do the half of both. Just do the half of the one. Or you can just do the 2 multiplication divided. All right? Or if you want to do mental math, what's half of 24? 12. 7 times 12 would be 84. Half of that would be 42. Boom, boom, boom. Nothing's going wrong. Okay, 84. And then 84 times 4 would be 337. All right. Good? Yes, ma'am.
Why did you divide the
Because the 480 was, oh, you're talking about what? The 480 divided by 10 was because that's linear. The end is squared. You got me? So we talked a little bit about it the other day. So if I do it for you visually, all right, there's 1 square centimeter. That's a pretty good square centimeter, if you ask me. All right, 1 centimeter is 10 millimeters. So that's what it would look like if we converted it. All right, so what's 10 times 10? 100. So that means 1 square centimeter is equal to 100 square millimeters. So that's why in the end, if you convert, you got to do it by. Make sense? Okay. Everybody else good? All right, so given a kite with the following information, the sides are in a ratio of 17 to 10. The diagonal connecting the non-vertex angles, which measures 8 centimeters, divides the diagonal connecting the vertex angles into a 5 to 2 ratio. The perimeter of the kite is 27 centimeters. Determine the area of the kite. Step 1, draw a kite. Woohoo! Drawing a kite. You want to put a little string at the end, pretend it's flying up in the air, bring it back to after days. You go right ahead. Whatever helps you at the end of the day. All right, so the sides are in a ratio of 17 to 10. So hopefully by now, from all the work we've done with ratios this week, both in class and at home, you recognize that that's how we would represent it. 10x, 17x, 10x, and 17x. Everybody good with that idea? Because there's a common multiplier. Good? The diagonal connecting the non-vertex angles, all right, divides the other one. Okay, so now I'm going to draw both. If that diagonal measures 8, what can we label both parts of that diagonal with? 4. So these are both 4. And of course, they make what kind of angle? Right angle. Right? Good so far? All right. It then says that the other one into a 5-to-2 ratio. Ladies and gentlemen, we got a pair of ratios, so we're going to have to use a different letter. Other than that, we're good to go. 5y, 2y. And then it says the perimeter of the kite equals 27 centimeters. So I'm going to come up with the equation 54x equals 27. Everybody understand where that comes from? Anybody not? Okay. All right. And then I'm going to divide both sides by what? 54, and x comes out to be 1/2. All right. And then we're going to plug that back in. What's half of 10? 5. What's half of 17? 8.5. 8.5. And 5. Oh, it miraculously works, thank God. No one remembers. Okay. So we got one thing left to do. Find the length of the other diagonal, correct? Okay. So we got 4, 4, 5, 5. Don't know what 8.5, 8.5. We got right triangles, so what they're dagger in. 4 and 5 that are now in the right spot. What does that make that? 3. Make sense? So 2y is equal to 3, so y is 1.5. Everybody okay with that? Okay? This is 4, this is 5. So we have, you can either use regular Pythagorean theorem to get that side length, or the triples, 3, 4, and 5. Because the 5's in the right place. Or you can just use regular Pythagorean theorem, square root of 9, right? So you can do it that way as well. So that means 2y is equal to 3. So y is equal to what? 1.5. All right, makes that 3, makes this 7.5. All right. Now do I have enough information to get the area? Absolutely. 1/2. The one diagonal is 8. The other diagonal would be what? 3 times 7.5 or 3 plus 7.5? 3 plus 7.5, which I believe gives me 10.5. What's half of 8? 4 times 10.5 gives me 42 centimeters squared. All right. So everybody good with ratios and proportions, since we did a lot of those in the homework and this. Did you expect one tomorrow with the ratios? Absolute gosh, chicken loop. All right, now for the fun one. Given an isosceles trapezoid with an acute base angle measuring 54 degrees, the longer base measures 16 centimeters and the shorter base measures 10 centimeters. Find its area, round it to the nearest hundredth place. As soon as you see round, what should you think of rhymes with pig? Trig. That make sense? All right, so I'm going to draw myself an isosceles trapezoid. or as best I can. So these two legs are congruent. This angle's 54. Boom, shakalaka. It says the top base or the longer base measures 16 and the shorter base measures 10. Ladies and gentlemen, as best as I can, if that passes through the midpoints, not of the legs, but the bases, so it's not the mid-segment, that, my friends, is a line of what? Rhymes with symmetry. Symmetry, divide it right in half. Make sense? So why that helps me is if this is 10, down here would also be what? 10. So can I get these two outer portions based upon the symmetry? Absolutely. What math you can do with 16 and 10? So think about it. So I'm trying to get this small portion here. That's 16, that's 10. These are congruent. Do you agree? So we'll do it that way. We'll draw it out. So those are x's. All right? So now what do those two portions of the segment add up to? Rhymes with mix. 6. Good? So that means x equals 3. Good? So x equals 3, and that's a 54-degree angle. Is that going to allow me to get the height of the trapezoid? Yes, it is, using trig. That's the opposite. That's the adjacent. No hypotenuse involved. Which trig functions it got to be? In the summer, we get a tan. So the tangent of 54 degrees equals the opposite, which I'm going to call h, so I know that I'm getting the height, over the adjacent, which is 3. Good? All right, so now I'm going to do 3 tangent 54. Gives me 4.129, which rounds to the nearest hundredth place. Would give me about 4.13. All right. Area equals, scrolling on down the road, 1/2. The height, which we found to be 4.13. And then the sum of the bases. What would 10 plus 16 be? 26. All right, what's half of 16? 13. So you would do 13 times 4.13, and you would get approximately 53.69 centimeters squared. Boom, shakalaka. Good. Yes, ma'am. We're going to have these tomorrow for you. You're going to be in school tomorrow, right? I'll be right here. We'll just wipe them down a bit. Sean.
Another question. How do you know which diagonal is non-connected?
You got to go back and look up your vocab. It's associated with congruence. So vertex angles connect the vertex angles connect the congruent sides. The non-vertex angles connect the non-congruent. And the non-vertex angles are always congruent. So they're your congruent angles. So just go back and just read through that in the terminology. I think it was section 6. Just some vocab. Yes, ma'am. Yes, in here. And you'll be provided with paper if you want to work on things. Liz will still be in Edgewise, just so you know. All right, now, a couple things about this quiz. All right, we want to clarify. Number 1. All right, and people at home, you can play this game as well. All right, number 1. Does everybody understand what exact means rolling into the mark? Fractions, radicals, we're not doing anything with decimals. So all of you put like 14.8 instead of 14 and 7/9 last week. You get it now. Fraction. Or it's a radical. So everybody understands exactly. All right. Now, number 2. When it says for work in Edge Elastic, show what equation you plugged in for. Show the value you showed in for. What I do not want is area equals 1/2 D1, D2. That is not what I want. I want the actual values you plugged in. For you guys, it's not as important because you'll be here. I'll be able to explain this to you. But for the people at home, I do not want that. I want the values you plugged in. And the reason being is that's for your advantage. Because if this is wrong, but that's right, then I can give you partial credit for what that is. You got me? All right. So make sure that's what you're showing, not this. Okay, not that. Everybody good? Yes, sir. Well, it's gonna be number. So basically, what it'll be is area will be like the first box, like it normally is, and then like formula you use. You know what I mean? So there'll be different boxes for it. So if it just asks you for the area, then you don't even worry about it. But then if it says formula used, all right. Now, technically, should you write area equals 1/2 15 times 12? Yeah. But if you like wrote 1/2 15 times 12, I get it. You know what I mean? So do the best you can in terms of showing the formula you use. All right. Same thing with Pythagorean theorem, that kind of stuff. Yes, ma'am.
Are all the policies that area?
What else would they be on since the quiz is just 10-1, 10-2 area? What do you think? I'm just going to find problems out in the wilderness? Bear walks into a tree. What do you mean? Are they like, yes, they're all. Ms. Pascucci, in all seriousness. 10.1, area of parallelograms and triangles. 10.2, area of kites, trapezoids, and rhombi. Just so the last two sections we've done. So everything we've done since the last week. All right. Like, could I ask you for perimeter based upon area? Yeah. Could I ask you for like a side length based upon area? Yeah. But I'm not gonna like. So when you say is it all on area, could there be problems where you have to work backwards and do something else? Sure. You know what I mean? Like if I said, okay, if I gave you this figure and said, all right, that this is 3, that's 5, all right, and then that's X, and we say the area equals 24, find X. So it might be something like that. But area is going to be involved in it in some way, shape. Yes, sir. Is there going to be another study guide? We're going to talk about that in a second. I just want to make sure we got all this clear. Okay. So in terms of studying, and this is the danger with a study guide, and this is what I've realized recently. If I give you a study guide, many people are under the assumption that the study guide covers the entire quiz. That's a mistake a lot of us have been making. And let's talk about that for a second with the last quiz. So for example, and I'm going to stop sharing for a second in case, all right, I see anybody's grades by accident. I don't want to do that. So I'm going to do this as well. I want to make that mistake. So we're going to do this for a second. Edge elastic. Okay. We're going to look at the quiz from last week. Authored by me. 10.1, 10.2. That's Happy Days edition. Next. All right. No. There we go. Okay. So that was problem number 2 in some way, shape, or form last week. The junior prom committee is decorating one of the walls of the gymnasium with a mural. The design for the mural is a rectangle 15 inches wide by 9 inches high. That was in your homework. So when you say, is there a study guide, I'll give you additional thing in practice, but please realize that's not limited to that. That makes sense to everybody? Because I think that's the problem we have, because that was run right out of the homework and right out of the class discussions we did. So in terms of a study guide, then we get the miscommunication of, oh, we were never told that. Well, you were. So I don't want you thinking the study guide is it. Because geometry isn't like algebra. Here's not 30 problems, and tomorrow's the quiz on those 30 problems. And you're going to find as you progress in high school, the same is going to occur. That too many times we think, okay, we'll just get 30 problems the night before and just redo them. That's great, but that's not what we're out to do. We're out to develop your critical thinking skills. So to answer your question, if I get out of this quiz and go back to sharing with the home folk, is that now? Share. Okay, go back to Edulastic. So this is what you got now, 10.1, 10.2 honors review. I'm going to assign it to you in about 7 minutes when the bell rings. All right, so what's in there is a series of problems like these. Okay, so the ones we've done in class the last couple days. So the higher level order thinking, so those are all theirs. So side lengths of a rectangle are given as 3x minus 4 and 6x units if its area is 98 square units. What are its dimensions? What is its perimeter? So that's a quadratic. 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 Right? And then a ratio problem and working backwards. All right, isosceles triangle, working backwards. 60-degree angle, so working with special right triangles. All right, working backwards with a rhombus, and then a trig problem. So that we review all those things. So that's in there if you want. It'll be open in a second. And the answers are there as soon as you submit, it'll give you the answers. It'll be there through tomorrow night. So look at it all you want. It's not mandatory, but it gives you more practice. If you have a question tonight, I got a tutoring session around 7 to 8. At 8 o'clock, I'll check Google, see if any of you have questions. But if you don't, I'm assuming everybody's good. So those are there. If you have a question about that one, feel free. Also, in the back of your textbook, there's review sections at the end of the textbook. Okay? And again, this is all optional. All right? Basically, all right, in your book, 10.1, here's more problems with area. All right, 3 problems just like those from 10.1 where you have to divide it up. All right, now tomorrow, for example, you have choices. If you look at 42, when we originally did that, we did that as a triangle and a parallelogram. You now should be able to do that simply as a what? Trapezoid. All right, those types of things. At the end of 10.2, more problems. All right, you may want to take a look at, for example, on page 627, 33. That's not saying it's on there, but that's an idea, because that's a coordinate geometry where they're not horizontal and vertical lines. And if we have time in a second, I want to go over that one from the homework last night. So I would look at that. And then at the end of the chapter, there's more problems that are reviewed. There's the 10.1, parallelograms and triangles, all right? And then 10.2 with more, all right? So basically, if you're looking to study, if you study your homework, if you study the problems we've done the last couple of days, that's generally what all the problems are going to be. You got me? And then you got additional practice there you can look at. So it's not like I'm going to grab anything and do that. Now, in terms of that kite, this is what I want to talk about. Because what you want to do when it's coordinate geometry, and I honestly haven't written it yet. I haven't written the quiz yet. I'm going to write it today. All right? So here's Google Classroom. We'll put that back up. All right? And then here's the 10.2 solutions that people were supposed to ask about. Not a big deal. All right? But this is what I mean. So if you look at the coordinate, and you'll have one of these tomorrow, coordinate geometry. I don't know what figure it'll be yet. But those are horizontal and vertical, correct? Horizontal and vertical lines you should be good with. Same thing here, horizontal and vertical. Here, all right? Now it's not horizontal and vertical. However, it's got a slope of 1, which means you're going over 1, 2, 3, and up 3, 1, 2, 3. So you can use distance formula or Pythagorean theorem pretty quickly to get that length, which would be 3 root 2. Same thing here, down 1, 2, 3, over 3. That's also 3 root 2. All right, so in terms of coordinate geometry, it'll either be a horizontal or vertical line, or it'll be something you can do real quickly, like a small one. Like maybe it goes over 3 and up 1, that kind of thing. All right, so make sure you're aware of that. The reason I bring that up, and I'm going to go back to the other quiz, all right, because this, and I get it, you didn't have a problem exactly like it, but here's the idea. All right, and as long as you answered something, you got 2 points. That problem. Okay, that problem. 37, 11, 7, 3, 3. It was an application of the altitude and the geometric mean. I was kind of surprised at how many people didn't get this. Because I don't think this problem is above your level. All right? That's a vertical line, ladies and gentlemen. So you should know that on a vertical line, the x coordinate is going to stay exactly the. So all you have to do is put in 3, and you got 3 out of the 4 points. That's it. And then you get the y coordinate. How far is it from 3, 7 to 11, 7? 8. How far is it from 3, 7 down to 3, 3? 4. 4, 8. Now it's a geometric mean problem. 8 squared, 64. 64 divided by 4, 16. Makes that 23. Like, those are the little things that, yeah. Okay, so in other words, the 3 walking in the door, you should know how to do no matter what. It's a vertical line. We talked about it. That's 3 out of the 4 points. If you answered something, I put 2 out of 4 points. The idea is never leave anything blank. Because there's some people in the last quiz, and I posted the grades last night because I had to work with them a lot, that left this blank. That left that blank. That's 12 points you threw away. You can't leave anything blank. It's 12 points out of a 70-point quiz. 12 points. See, you can't leave anything blank because you're not giving me anything to work with. You got me? So in other words, if we go back to that problem and you give me something to work with there, so if you gave me any number, so if you gave me any number bigger than 7, at least you understand coordinates. I can give you something for that. I don't grade on what you don't have. I grade on what you have. So as long as you show me something with knowledge, that's why I'm asking you to show me the area of a figure. Because if you show me the area, you're showing knowledge by knowing what formula, what figure is. So if you have a picture, if I show you a picture and I don't tell you it's a kite, and you show me area equals 1/2 D1, D2, are you showing me knowledge? Yeah, I can give you points for that. The problem is people are looking at stuff like that and saying, I can't do it, and just giving up. You can't give up on a problem. I'll work through it. Okay? I'll work through it. So remember that tomorrow. You'll be here. I'll remind you of that. The only other thing I want to talk about is, because we went through it quickly, you guys were walking out the door yesterday. Want to make sure we all understand. All right? Is these problems. Because I think we did it. Did we do it quickly going out the door? Hold on. So it's the right angle figures. All right. So it's the right angle figures. So John, I have to give you a copy of it. It's up on Google Classroom if you need a physical copy. All right. But for these problems, all right, here's the idea. All right, here's the idea. Let's move this over. All right. So here's the idea. So for all these problems, the perimeter is equal to the area. So that's what you start with. That's your guideline. Perimeter equals area. All right. If this is x, this is also what? X. If this is 3, this is also what? 3. So if I do the perimeter, I'm adding up all the sides. So what do the numbers add up to based on that? 6. What do the variables add up to? 2x. To get the area, I multiply the sides together. I multiply the sides together. Well, what would that be? X times 3, which most people would write as what? And now you solve for it. That's all we're looking for those, okay? So that's the first 3. That's A, B, and C. Now down here, it's a little different. We got to go through this. Irregular shapes, it says to divide into what? Rectangles, okay? What you have to realize with these is opposite portions have to add up to the same thing. And this is what I mean by that. See that, which is 3? That means over here, those portions also have to add up to what? 3. You got me? So if those add up to 3, and that's 2, all right, dang it. Hold on. Hold on. There we go. Okay. This way everybody can see. All right, if that's 3 and that's 2, you should be able to get that sidewalk. You got me? And then the same thing here. If that's 1 up there, what should it be down there? 1. And still, same thing. Perimeter equals area, and you set it up from there. To do perimeter, you're just going to add up all the sides. To do the area, you're just going to do the separate rectangles like we did. There's nothing like this tomorrow. And as long as you show me the setting up of perimeter and area and show me work, it's 10 out of 10. It's a homework assignment. All right? If you don't show me work or hit in late, then you got to lose points. But I think there's 12 of them. 6 of them, so it'll be 12 out of 12. All right? So it's 2 points for each one. So as long as you're showing me perimeter area and something that makes sense, it's a homework assignment. It's kind of like the writing assignment. All right? That we gave you. All right? But none of this is on the quiz tomorrow. Good? Okay, so tomorrow's the quiz. We'll go from there. Those of you playing the home game, have yourself a great day. I will be in the 910 library, but okay, with math lab today. Otherwise, good luck studying. If you have any questions during the Edge Elastic, you can send them in Google or somehow, some way, and I'll try and get back to you. Anybody looking for physical extra help, I'll be in the library today.
I'm going to.
You can use regular pen.
Okay, but do you use the 2 light or do you?
You can, well, with this,
Oh,
use y is 1.5. 2 y is equal to
Or you're solving for y.
if you use Pythagorean theorem, you can just do the 3. You don't need the 2y.
But you don't know that.
Right, you don't know that it's 3. So there's 2 different ways to do it. You got me? So if you have, like, if people went at it different ways, then you would have had to use the y. But because we did that first, you didn't need the y. So when we're looking at this, we didn't need the y, right? We didn't need it. Yeah. Not needed. However, all right, if we had used, the idea is if you had not recognized, so once we got the 3, we didn't need the y to get the 7.5. We could have used Pythagorean theorem on that. Yeah. So the idea is you could have used Pythagorean theorem for both, or you could have used the y's and go from there. So it's like different ways to look on the problem. That's all. You got me on that one? Yeah. Okay. That's all. Yep. You're welcome.